Well, hello. Who would want to sit and have a view like this, okay, when you could be doing a chi-squared test for independence? So this is 10.2. Okay, now I got a bunch of stuff on here, but I'm going to use example 3 on page 556. And we'll come back to this because I want to help you see what your focus should be when you're doing your test as far as the numbers go. So here's the example in the book. I got a lot of stuff scribbled around on here. But anyways, here's what they give you. And see what I have circled here. These are the numbers you're going to use as your observed numbers. So we're still doing observed versus expected. Okay. But they give you a lot of information there. So we're still doing observed versus expected. That's what I had circled. That's your observed. Okay. Now we have to use something called matrices if we want to use our calculator to come up with our test statistic. And matrices are always row by columns, so we have 2 rows by 4 columns, and that's important for our degrees of freedom and also entering the numbers on our calculator. Now, by simplifying things down these last couple of weeks, I can emphasize certain things which are simple but very important. To test, we need 2 things, right? We've been doing this over and over again. A critical value and a test statistic. You compare those two and decide whether you're going to reject or fail to reject the null hypotheses. Look at critical value first. So it's like 10.1 in that we're going to be using the chi-squared table, okay, that you did yesterday and the day before, okay, at table 6. It's not like 10.1 in that the degrees of freedom are found differently. It's this, which means you take the number of rows and subtract 1, and the number of columns and subtract 1, and then you multiply the 2 numbers together. So it's a 2 by 4 matrix. Subtract 1 from each. 1 times 3 is 3. That's your degrees of freedom. So your degrees of freedom are 3. In this problem, alpha is 0.05, and the critical value we come up with is 7.815. So you go to your table, right? There's your degrees of freedom. We come across until we're just under the 0.05, right? There's 7.815. Okay. And you've seen chi-squared naught is the symbol for the critical value. Next, test statistic. Okay. So we're going to use chi-squared test, not chi-squared GOF test. You go get that right. You go to stat, then to test, and then chi-squared test. Now, when you get there, you'll see observed expected, and they'll have this stuff here. Well, what is that? How do you get that? Okay. Well, those are names for matrices. So again, when you go to your test, that's what it looks like, and those are names for matrices, the A and the B, okay? So, but how do you get those? Well, the main one we're going to focus on is A. How do you get A? So right here you can see matrix, so I have to go second matrix. We come here, and there's names. Now I already have these in. You first need to enter your number. So you go to edit, and you choose number 1, or please do so. You have to tell it what the dimensions are. You just hit 2, enter, 4, enter, and it's going to take you to that spot right there. That spot is right here. So you're just going to work your way across entering the numbers, and you can see how I hit enter, how it works its way across, and it jumps down to the next row, and you work your way across. Just be double checking, triple checking that you're putting your numbers in right. Okay, now after you put these numbers in, you want to quit. Otherwise, it thinks you're still in the matrix. Okay, once you've done that, now you can go to stat, and go to tests and go to your chi-squared test. And I think your guys' calculators will have these on there for the names. Otherwise, you go to matrix, go to name, and you choose those names. But there's B, right? You don't have to worry about B. It will do that for you. You won't even have to look at it, okay? So you go ahead and you enter those, you tell it to calculate, and here's what you get. There's your test stat right there. And that's that probability, right? Maybe we'll come back to that. So we got our test stat, right? So now we can compare, right? Still right-tailed testing. Okay, so there was your critical value. There's your test stat. So obviously you're not rejecting. You failed to reject the null. Okay, and when you set these things up, remember it's a test about independence. So we'll talk about that a little bit more now. Okay, so they're comparing gender with days per week spent exercising. Okay, and they want to know and here's the thing, is there enough evidence to conclude that the number of days spent exercising per week is related to gender, whether you're male or female? Okay, so you're saying, is there some connection there or not? So the null will always be that it's independent. Okay, there's no connection, and the alternative is that it does depend. So if I'm male, there's a difference in the number of days I spend exercising per week compared to if I'm female or vice versa. Okay, so we found that we're going to fail to reject. Okay, so we're going with this, that they're independent. And then here's what they said. Is there enough evidence to conclude that the number of days spent exercising is related, is dependent? Okay, well, no, we decided, okay, independent. So the interpretation is there is not enough evidence to conclude that the number of days spent exercising per week is related to gender.